So we all had to file industry card, and the card was actually out, and we were like trying to figure out how to do so bad. She was on the
Okay. Shh. Everybody quiet for me, please. So you should have this paper. Okay. So basically, it tells you ternary compounds are compounds that contain 3 or sometimes more elements. So when you see that word ternary, you're thinking of 3. Okay? Now then, we will only deal with ternary ionic compounds, or in other words, the ones containing, what did I call these? Okay. This paper right here gives you the formula and the charges of the polyatomic ions. All of them are anions. What position do anions take in chemical formulas? Bad for you if you don't know. Where do the negatives go? Front or back? There. That's what I'm looking for. They bring up the rear. Every one on this sheet brings up the rear in the formula except one. Right here. This one is the only polyatomic that functions as a what? Cation. All the rest of them are anions. Okay? Ternary ionic compounds are named in the same manner as binary ionic compounds. Name the cation first, then the anion. Now, these are even better than naming binary ionics. Their name is given to you on your paper. What did I just say? And if you look at the ending on their names, the majority of these end in what? 8 and at. Okay? 8 and at. Now then, when you get down here, you're going to find that some of these, if you look at the CLOs right here, does everybody see them? Right down here? Hypo is a prefix, hypochlorite. Chlorite, chlorate, perchlorate. Their name is based off of the number of O's. This one is 1, 2, 3, and 4. The charges never change, but the name changes along with the number of O's. Okay, now we're going to add the bromines and the iodates. So over here on the left side, we're going to put BRO minus 1. We're copying the formula, substituting Br for Cl. BrO2 minus BrO3 minus and BrO4 minus. Okay, so everybody write that down. Now then, let's look at it. This one was hypochlorite. This one will be hypobromite. Okay? Take off the prefix and the ending and put it on this one, hypobromite. This one is chlorite. This one will be brom what? Bromite. This one is chlorate. This is bromate. This is perchlorate. This is perbromate. See how that works? Okay, now we're going to do the IOs. So IO minus IO2 minus IO3 minus and IO4 minus. This one is hypoiodate. Okay, this one is iodate. This one is iodate. And this one is periodate. Okay? Questions? All right. Now then, the compound must be what? That means we assign charges and do what? What was the purpose of assigning charges, and then what did we do with those numbers? I heard it. Crisscross. Okay? Alright, mark this out. Remember, aluminum is written in stone as a +3. You can put aluminum up here as a +3 so you don't get confused. Now this is critical. Star this bullet right here. This other stuff you already know. Okay, if more than one of a polyatomic ion is needed to balance the charge, that means when you crisscross more than a 1, the polyatomic ion must be put in what? Star it, and do not forget it. Most ternary compounds end in what? Okay, but you don't have to memorize them. You're going to read them off of your polyatomic sheet. Does everybody understand? All right. So, get your little polyatomic sheet handy. Now, please pay attention. Remember, your metal is always in the front. So, this is a metal plus a polyatomic. Okay? So, the first capital letter with whatever is behind it is always going to be your what? Metal. Cation, that's right. Okay, what is the name of Mg? Write it down. Go find SO4 on your polyatomic sheet. Go to the -2 charge. Sulfate. You have to pay attention to the number of O's, don't you? So its name is magnesium sulfate. It's that easy. It's called read it off of your polyatomic sheet. Okay, right here. Who is K? Go find CO3 -2. Everybody see it over here? Lives right here. Last name is carbonate. Okay. Who is Cu? What is wrong with copper? It is. So we know we have to have a Roman numeral. Now, let's look at our formula. Can you tell that this is a 1-to-1 ratio? How do you know? No subscripts. Does everybody see that? No subscripts. So, everybody go find Cn. Cyanide. Everybody see it here? What is the charge on cyanide? -1. Okay, so that means copper was +1 and this one a -1. Does everybody see that? So it's copper who? And then the last name. Questions? Okay. Going over here. Who is CD? Can somebody tell me why ClO3 is in parentheses?
Because you need two of them to balance it out.
Exactly. Now then, if they did not put ClO3 in parentheses, it would have become ClO32. Is that correct? No. That's why you have to put, when you do crisscross, that's why you have to put the polyatomic in parentheses. So if you will remember, their formula is written in stone. It never changes. So what this is telling you is that cadmium is hooked up to how many ClO3s? 2. Okay? So, cadmium. Who is ClO3? Chlorate. Okay? And what's my name for Al parentheses NO3 parentheses 3?
Aluminum nitrate.
Exactly. You're simply reading the formula inside the what? That's the only thing you're looking at to name it. Does everybody understand? Okay, so now we're going to write some formulas. Okay, what's the symbol for sodium? Periodic table. Group 1 metal, what's it charge? Go find arsenate. It's down on the bottom on the left side. ASO what? Negative what? Okay. It's not a 1-to-1, so we crisscross. Who gets the 3?
Sodium.
Na3, and then simply copy your formula. AsO4. You don't care what the polyatomic formula is, you're copying. You don't have to deal with anything about it except write it. What's the symbol for silver? Ag plus 1. Go find acetate. Now sometimes, remember, none of these live on the periodic table. They all live right here on this sheet. Acetate can be seen as 2 different formulas. This is the one I like to use. This one is the structural formula. But if you'll notice, they're the same. 2 C's, 2 C's. 3 H's, 3 H's, 2 O's, 2 O's. Everybody see that? Okay, just a different way to write it. Same thing for hydrogen carbonate. I don't use that name very much because I like to use this one because what do you see in the formula? Hydrogen. Okay? But both names are listed here. Alright, so going on with our formula writing. C2H3O2 minus 1. What do you see about your charges? They cancel out, so it's a what to what ratio? Okay, so Ag C2H3O2. Again, you are literally copying on these polyatomics. Does everybody understand? What's the symbol for lithium? What group? Okay, that bicarbonate I just talked about, what's its formula? Minus 1. Again, we have a what to what ratio? Okay, so Li, HCO3. Questions? Symbol for chromium. Cr. What is the Roman numeral 2 telling me? plus 2. Go find hydroxide. It'll be a minus 1 up in the top left. OH minus. Now this is the first time we are writing a formula where we have to crisscross and put our parentheses. Who gets the 2? OH. So we write Cr parentheses OH, because that's the formula of the polyatomic with the 2 outside. What is that telling you? It's telling you Cr is hooked up to how many OHs? There you go. Without a parentheses, your formula is wrong. Okay? Group 2 metal, Ba plus 2. Go find perchlorate down on the bottom where we wrote all of those. See that formula? There you go. So ClO4 minus 1. Alright, crisscross, who gets the 2? Okay, so I write Ba parentheses. I write my polyatomic formula inside. Close it and put my 2 on the bottom outside. Questions? Alright, this is our one and only polyatomic that functions as a what? Cation. So it's NH4 plus 1. Okay, now this is chlorine off of the periodic table. You see that IDE? Somebody tell me that when I mix it all up, how are you going to know the difference? Yes, the IDE for the most part is telling you that it's binary ionic. Now then, you can also look at your if you look at all the ites and the eights with chlorine, there is no IDE. Does everybody see that? Hydroxide and cyanide are the 2 that end in IDE for polyatomics, and that's very easy to not mix up with chloride, isn't it? Okay, so this is Cl from the periodic table. Group 7 is a minus 1. Okay, 1-to-1 ratio, yes? So NH4, Cl. Questions? All right, your assignment. Guess what?
Left side.
Left side, front and back. Naming goes so easy. Where do you have to be careful? Okay, in naming. Who are the problem children in naming? Transition metals. Uh-oh. Let's look right here. Okay, where'd my 3 come from? In crisscross? Undo the crisscross. So that's chromium what? Chromium. Roman numeral what? 3. Sulfate. See, it's really easy when they have those subscripts. Okay, now let's look right here. Can you tell it's a 1-to-1 ratio? Why? There's no subscripts. So go find SCN. See it down on left side? Its charge is a minus 1, so that makes copper have to be what?
Plus 1.
Because SCN, thiocyanate, is a minus 1, makes copper have to be. So it's copper Roman numeral 1, thiocyanate. THIOCYANATE. Look right here. Who's in H4? So write it down. Your only polyatomic cation. Go find MnO4.
Permanganate?
Permanganate. Write its name. Are you having to do anything special with these polyatomics? No. You're reading their name. You're reading and writing their formula. Does everybody understand? Okay. 10. What do you get to do? Undo the crisscross. HG on 11. What are you going to do? Undo the crisscross. All right. Look at 13. Here's my metal. Who is it? Cobalt. So we know its name is cobalt. I know I have to have a parentheses. Go find Cr2O7 and find its charge because it's a 1-to-1 ratio with Cr2O7. How do I know?
-2, so it has to be.
So it's cobalt 2.
That's right. If this was a -2, this one has to be a +2. So cobalt 2, who? Dichromate. Think you can handle it? All right.